Hi everybody, I'm Saket, and today I'll be showing you my implementation of elastic collisions in the NBody project for CS61B. So over here I just have a simulation of the regular planets that we used in the NBody project, and I just wanted to show that it still works and it's good to go. But I have to show you elastic collisions because that's what I promised, and you will get some. Okay, let's see some elastic collisions. I just have to load up the data set that I used to test and create this project. Okay. So as you can see, this is actually a pretty complex collision with about 4 planets, and I'm going to tell you about some of the problems I ran into and how I solved them, at least in my implementation. And you can see like Mercury just got shot off into space, and goodbye. Okay, so I'll get into what some of the problems I had in this project. Let me just run the simulation again just to see. So for the first problem was to actually get the radius of the planet, because what I wanted to do was to check if the images of the planet were colliding or touching each other. So you might ask how the radius of the planet is enough to get that information. It's because what I used was the radius is not given anywhere in the project. The only radius that we have is the radius of the universe that we get from the data set that we import. So what I did was I created a scaling factor based on a proportion of the radius of the image of the background, which is about like 250 something, over the radius of the universe equals the pixels of the image, which is like the sun or the earth, the Mercury or whatever, like that PNG that we get, over the actual radius of the planet. So I couldn't just Google some radiuses off the internet and get some radiuses based off of that, because as you can see just off the simulation, Venus, I think, is almost the same size as the sun, which is definitely wrong. And if we were to use that, we might have issues with the planets colliding before they even touch each other, or they might collide only when they overlap a lot. And visually that looks really bad. And I wanted to do it based off the images touching each other, because that would look nicer. And basically what I did was, once I had the radius of the planet, was to then create a formula that detects whether any two planets are touching each other. So what I did was I just used the simple Euclidean distance based off the centers of the planet, which is given to us, that's in the data. And we constantly update that based on the old NBody project. That was just part of the project. We update the centers, we update the position, and what I did was, if the Euclidean distance between the two centers of the two planets is less than the sum of the radii of the two planets, that means the planets are slightly overlapping, or if they're equal to each other, that means they're overlapping, or they're just touching. And once I had this information, I could detect whether or not planets collide, and I could use the elastic collision formulas from physics to determine what I need to do based off of that information. So one of the data sets that I used was a simple collision between two planets that would help me debug issues, and you're going to see it right now. So we have the Earth and Mars just coming together and hitting each other. Some information background on these is the Earth is about 10 times heavier, I want to say, than Mars, and basically, well, you can see it actually right here. It's Earth is to the 24th power, Mars is to the 23rd power. It's about 10 times. Earth is about 10 times heavier, so it's going to have about 10 times more momentum, because the initial velocities are mostly the same. Yeah, they're different, but they're mostly the same. So Earth has about 10 times more momentum. And basically that will allow Earth to keep going forward, even though Mars shot off in the opposite direction. It still has that momentum to keep it going where it needs to go. And it transfers some of that momentum to Mars, and it shoots off in the opposite direction, which is characteristic of an elastic collision, which is important. Enough physics. This is CS. Okay, so so that's one of the functions that I need to get working. I needed to change the momentums of the objects based on collisions. But that wasn't enough. That wasn't the only problem. What would happen in this collision originally was, let me show that again. So what would happen originally is that Earth and Mars would collide, but they would go through each other. And that took a few tries to figure out, And that was basically, the issue came from the fact that once they collided, my function would simply just check whether the planets were like overlapping, right? So if they're overlapping, it would change the momentum again. So the momentums would keep swapping continuously, as if like the collisions kept happening as they were overlapping. And basically what would happen is like they would cancel out and cancel out again and just keep going through each other. And that was an issue. So I needed to check if planets had collided before. And what I did to do this was create some instance variables about whether or not the planet is currently in a collision or is free to collide again. And basically what happens is when the planets collide, I change this collision instance variable to false. They cannot collide anymore, which means the objects have to continue with that final velocity that I calculate using the elastic collision formulas, and they move apart or do whatever they need to do. And this allows me to have the collisions to actually work and they don't go right through each other. And that was important for this project. Another issue was so I'll show you some more collisions and I'll show you some tests that I needed to do to make sure that this was actually working. So this is Mercury and colliding with the sun. As you can see, the sun is really heavy. It's about 10 to the 7 or something more than mass than Mercury. And because of this, the sun doesn't move at all, but Mercury just kind of bounces on there. That's just a problem with the fact that we're using elastic collisions because, realistically, when Mercury collides with the sun, it would burn up and turn into whatever it turns into. And we need to keep into account what this is. This is just it looks really comical, but that's just the fact of elastic collisions. And I know this simulation is correct. Let me show it again. Because since the sun has a lot of mass and the Earth and Mercury has much less mass, it does what it's supposed to do and kind of just bounces until so the reason it shot off like that is I'm predicting based on the fact that we're still using the forces and gravitation formulas. So Mercury gains some acceleration and shoots off. But I can't be sure. I have to do some more testing to figure that out for sure. And finally, for fun, I'm going to show you one more simulation, and that is the spiral simulation created by the 61B staff. And I thought this was just interesting. Oh, I did that wrong. I thought this was interesting because there was a lot of collisions going on in this. So yeah, there you go. Lots and lots of collisions. And this actually goes on for a while. They come back. The Venus actually comes back later, and you can see the program doesn't slow down or anything based on the number of collisions we're having, and it's just a simple check before every time we calculate it. Same with the forces and everything. And I had to reiterate all the main points about this is that I implemented the collisions, elastic collisions every time objects collide with each other. Another feature that I actually added in the code but didn't end up working was the getting sounds to work when objects collided. I wanted an explosion sound to go off, but that just didn't work with the WAV files, but it did work with MIDI files, but MIDI files sound like a piano, so it sounded like a bunch of piano keys hitting every time they touched each other, and that was just kind of gross, so I removed that. But yeah, as you can see, this will actually go on for a while, and oh, if you saw that right there, the sun actually moved just a little bit because of all the collisions, and that's pretty interesting. I hope you enjoyed this project as much as I did, even though it was just looking at a bunch of simulations. But this was a lot of fun to make, and I hope the people reading the code will see that it had pretty interesting solution too. Yeah. So this is the final positions again, and that concludes the end of this program. Bye.